Welcome to this decarbonization showcase hosted by NYSERDA's Empire Building Challenge. Its purpose is to familiarize you with technologies and strategies to facilitate decarbonizing our building stock. All sessions will be recorded and posted to the EBC Showcase Series website. Each presentation will be 20 minutes, followed by 10 minutes in which the presenter will respond to your questions, which you can post in the webinar chat. And now it is my pleasure to introduce Margaux Peltier and Alessandro Rota-Loria of Enerdrape.
Thank you, Sal. Happy to be here, everyone. I'll start it with the presentation of Enerdrape. So today we're gonna present you the only non-invasive geothermal technology that we have developed. As Sal has mentioned, so my name is Margaux Peltier. I'm the CEO and co-founder of Enerdrape, and we have also with me Dr. Alessandro Rota-Loria, who's also based in Northwestern University, Chicago, who's also the CTO and co-founder of Enerdrape. So what we do at Enerdrape is that we transform underground spaces from parking garages to tunnels into sources of renewable energy, specifically for the heating and the cooling needs of buildings. So it's really a way to provide decarbonized heating and cooling by untapping the energy that literally lies under our feet underground that is present in this type of infrastructures. The, let's say, physics behind is the fact that everywhere on the planet, we have a more or less constant temperature a few meters down underground. That's the case everywhere. The temperature is changing depending on which region we are, but that's really a phenomenon that is global. In the United States, depending on the region, we will have around 50 Fahrenheit degree underground, a few meters down, which means that basically it's hotter than outside in winter and it's cooler than outside in summer. And thanks to this differential of temperature, we have the possibility to extract heat, decarbonize heat, and leverage it into renewable heating for buildings through ground source heat pump system. We have developed a geothermal technology that does not need any drilling. That's really our main invention and disruption that we bring to the market as of today. So imagine a panel that you actually place on underground walls that are in contact with the ground. So that's basically the wall of an underground basement, of an underground car park, also tunnels, subway tunnels as well. We're going to attach this panel on these walls is going to extract the heat that is contained into the concrete wall or indirectly through the stock of soil that is on the other side and a little bit from the air that we have on the air void as well. And thanks to this heat that we can extract, we can really plug it into a ground source heat pump system. We use, as of today, existing ground source heat pump that are already existing on the market. And thanks to this, we are able to leverage and bring higher level of temperature to the building. We can also do it on the other way around. So we can reverse the system, meaning that we can actually extract the heat from the building and inject it back into the wall through our panel system. So the technology is patented and it looks like this. You have also the dimensions there. It's less than an inch of thickness, so it's very suited for either retrofitting of buildings, existing infrastructure, or it can also be applied to new construction and new real estate developments. It's basically, you have basically two components. The main components is the geothermal panel, which is the element you can see on the left, where you have an aluminum-based panel with a layout of piping where water will be flowing inside these panels to collect the heat and bring it to the heat pump. And then you have the element and the component on the right, which is a protection panel that is here mainly to protect the geothermal technology, but can also be used actually as a communication tool to place advertisements, signalytics, have a better aesthetical integration into the garage, or to put branding or any kind of communication material on it. So basically, thanks to this technology, we are able to provide a plug-and-play solution for buildings with ground source heat pump system. So the idea here is that you don't need to excavate materials, you don't need to drill into the ground. So it's specifically adapted to existing and built environments or very dense urban areas where actually you might don't have enough place to actually drill or try to get the heat from the underground. In general, we say that 1 square feet of the technology, which is mainly one panel, is able to provide enough energy for 100 square feet of conditioned area in the building. Of course, it depends on the type of consumption the buildings have, but that's to give you an overview. From day one, as you will install the technology, you will have direct CO2 savings and decarbonize completely your heating fossil-based system. And as I was mentioning, you can even use it as an additional communication tool. As you can see on the picture as well, you can see the thickness, it's super thin. All with the protection panel, it's less than 1 inch of thickness, no footprint on the floor. And in general, in the projects that we are deploying, we never stop the operation of the building or the operation of the garage, for instance. So it can also give you an idea of how quick and easy it is to install. So the way it works, to simplify it a bit, is as it is. So you have panels that are going to attach to walls, earth contact walls. So in general, it's what we call the structural or the foundation walls of a building or of the infrastructure. These panels, they are connected together with pipes, as you have seen on the previous slide. Water is going to be flowing inside, and this water is going to be collected by 2 header pipes. The 2 header pipes are going to the technical room in general, where we have the heat pump, the ground source heat pump system. And then the ground source heat pump system is basically connected to the distribution system. As of today, we connect to several types of system. We connect with gas boilers, steam boilers, distant heating district, as well as overheat pumps. So there is really, let's say, a lot of modularity to how you connect it to the buildings. The key characteristic of the system is that you don't have to drill. It's very non-invasive. That's really our main innovation and the main characteristic of the Enerdrape system. It's very easy and quick to install. In general, we say that it's 15 minutes per panel is sufficient for the installation of the system. The maintenance is minimal. You will have the maintenance to do on the ground source heat pump system, but otherwise it's mainly a visual maintenance to do on the panels. It's also very quick and easy to replace one panel if needed. No direct CO2 emissions, as there is no combustion involved, as I was mentioning, and you have basically access to local, renewable, but most importantly, 24/7 available energy. That's also a main difference from other types of renewable energy system that are dependent on the external conditions, dependent on the time of the day. This is not the case with geothermal system in general, and not the case with Enerdrape as well. And we use recycled and recyclable materials for the panels. The panels are fully 100% aluminum based, which is actually one of the only metal that is 100% recyclable in an easy way and without, let's say, changing the mechanical properties of it. We are about the no-brainer of geothermal system. There is other types of geothermal system, and there, Dandelion geothermal, for example, is a big one in the United States. The main difference here, as I was mentioning, is that we don't need to drill. So basically, it's going to be potentially more fitted to built and dense environments, multi-residential building. We also provide not only an expertise, a know-how, and an innovation, but a product per se. You have this panel. It's an easy product also to deploy within one building. And in terms of power ranges, we are more or less in the same orders of magnitude of the other system. Of course, it will depend on the let's say the surface where we can install. Specifically, if it's an existing building, we need to assess how much surface is actually in contact with the ground and how much energy we can extract out of it. As of today, we are able to install the technology in underground garages, underground car park, but also underground stations. For example, in underground malls, you might have underground stations that are not conditioned, where we can actually install the technology as well to gather as much as energy as we can, and underground tunnels, infrastructure tunnels as well are possible. What we do with Enerdrape is we really provide a comprehensive solution to our clients. So first we evaluate the technical implementation. So how much surface is available, what's the type of soil, what's the environmental conditions, so we can really have a first overview of what will be the potential. Then we have the design. So we have a comprehensive analysis. We do the engineering and the thermal calculation. And something that is of importance is that we actually assess the source and the energy production over 50 years, so 50 years. And in general, in our projects, you're gonna, let's say, invest and install the system, and after 10 years, you will actually have a return on investment. So basically, we're gonna provide 40 years of energy for free for the client. Then, of course, we do the execution, so the supply, the installation, and the commissioning of the project, as well as the project direction. And we also continue to accompany our clients with monitoring and performance and reporting for them. So here's an overview, for example, of the comprehensive monitoring. So for each project, you will be able to see how much heating power, how much heating energy, what's the efficiency of the system, what we call the coefficient of performance, and what's basically the energy that was produced, the gas saved, mitigation, decarbonization KPIs as well. We have already developed several projects out there in Europe, because we are a Swiss-based company, but actually also in the US, and we have Alessandro Lataloia, actually my co-founder, who's based in the US, who's also participating to the development of the technology on the territory. Our clients and partners are mainly real estate owners, so multi-residential owners, commercial building owners as well, or we are also working with institutional owners, so that could be university, hospitals, administrations, and that type of owners. And we're also working directly with and partner with energy suppliers, such as Engie. Engie is mainly in France, has also an antenna in Canada. We also working with Endurant Energy in the US, and we are actually developing more and more partners there as well. So here is to give you a bit of an overview of two different projects. That's a project that we developed here in Switzerland. So it's a residential and commercial building, 2 underground levels. We installed 200 panels. And the main advantage for the client here is that they wanted to retrofit the heating system of the building. They had lots of constraints in terms of how to access enough sources to actually shift from a 100% gas system to a fully renewable heating production. So we installed these panels, providing 35% of the building needs, which allow them basically to couple the Enerdrape ground source heat pump with the air source ground source heat pump. Air source heat pump. And thanks to this combination, they have been able to actually achieve their goals of shifting to a fully renewable heating production, and save a substantial amount of tons of CO2 throughout the first 20 years of operation. Here's a picture of what it can look like. In terms of piping, we changed a little bit the way we install. And you will see some other pictures afterwards, but you can see that we can actually install on faceted walls, so more curvy, let's say, type of walls, and how also you can integrate your branding or a design to the panels. This is another example of projects, multi-residential projects. To give you a bit of an overview, it's 100 units of dwellings, and there is 5,000, so 50,000 square meter of commercial area. Again, 200 underground levels here. We installed more than 300 panels, providing actually more than 20% of the building needs. We are discussing with the owner currently to actually connect to a new building, because it's basically 5 buildings that are supporting above 2 underground levels. So we were able to provide so much energy that we can actually replace fully 2 gas boiler of this system. And here is a picture of the system before we installed the protection panel, to give you an overview of how it looks like when it's in phase of installation. So as you can see, again, very thin panels, plates that we fix on the walls. We connect them together with a specific methodology. We can place them vertically, but we can also place them horizontally to adapt to basically adapt to any kind of surface. And then, as you can see, I don't know if you see my mouse, but as you can see, very close to the ceiling, you can see the header pipes that are running throughout the walls to actually collect this heat, this water, and bring it to the technical room and basically to the ground source heat pump system. And that's, for example, some information regarding the heating season of that particular system. So we have been able to provide 120 million of BTUs of heat. We were not doing cooling on that system, and actually we were running at only 50% of our capacity. So that's why now we aim to connect to a second building, so we can actually, let's say, take advantage of the full capacity of the system. We have already avoided this year during the heating season 5,000 kilograms of CO2, meet 100% of the heating demand of one of the building, and have a seasonal coefficient of performance of 4.1, which is very good for actually heat pumps and ground source heat pump in general. With Enerdrape, we aim to have a meaningful impact on climate. We are committed to sustainability. Our goal is to reduce by 100 megatons of CO2 per year globally, which is basically the annual CO2 emissions of Switzerland, thanks to the activation of our projects. And as I was mentioning, we already use recyclable materials and integrate circular economy in our supply chain as well, to basically be as much as we can ahead of the future regulation in terms of material use as well in buildings. And here is our contact. Happy to take question, and let me know if you have any questions. Alessandra and I are here today to give you as much as info as we can.
Great, thank you so much. So we do have some questions that have come in. What types of surfaces are the panels able to attach to? Can these only be installed horizontally or vertically along the walls?
So yeah, it can, in terms of installation, it could be installed horizontally and vertically. It doesn't really matter. So in general, we're gonna try, let's say, we're gonna assess the best position of the panel to maximize the amount of surface where we can install to get the maximal capacity and the maximal power at reach. And in type of surfaces, so it should be walls that are in contact with the ground. Most of the case, it's concrete walls. Could be ideally it's cast concrete type of surface, but we have actually also the possibility to attach to more let's say rough surface, such as such as, oh, maybe Alessandro, you have the word in English. I don't have it right now. Parois moulées.
Diaphragm walls.
Okay, diaphragm.
Yeah. And in the meantime, I'm also answering the questions right away in the chat, but I'm here.
Great. Yeah, I'm also reading them so that the people watching the recording will have the benefit. Have you considered making your panels into tubes to surround wastewater piping?
So that's actually kind of possible as of today, because we can curve the panels. So of course it depends on the diameter of the water piping, but for example, for large sewage infrastructure, for example, placing the panels there, it's something that could actually be possible. And we have even a pilot case in Chicago, actually at the University of Illinois. We have installed the panels in a steam tunnel, so which is the same kind, let's say, of use case. So that's something we are working on. Yeah.
Great. How do the panels attach to the walls? Is there an adhesive or a mechanical connection?
So it's mainly a mechanical connection. It's basically 6 screws, so very easy to install. But for more, let's say, rough surface, such as diaphragm rooms, we have also the possibility to add in some kind of adhesive to have a better performance and a better contact with the surface. But most of the time, it's simply 6 screws and mechanical it's attached.
Connectors.
Yeah.
Great. In terms of the header pipes, are those typically insulated?
So it depends. Sometimes yes, sometimes not. It's not always a necessity. So for example, on the projects I showed you, we did not insulate them. However, sometimes we do it. It's mainly for condensation purpose, more than for specific thermal differences. But that's really more project case choice to do.
Great. In terms of the optimal opening size for where you install these underground, can you say something about the volume of the space and the underground conditions, and also its minimums, how constrained you can go to still get a optimal performance effect?
Yeah. So in terms, we don't have higher boundaries, for instance, because we can really stack them and increase the capacity. So we don't necessarily have higher boundary. We have a lower boundary though. In general, we tend to say that we will require so that's 10,000 square feet of surface where we can attach the panels. So more or less 100 panels, 100 units to be installed. And thermally, there is not a big difference. It's more economical, let's say, ratio that we are trying to get there.
In terms of the existing systems that you can connect to, you mentioned that briefly. Are there any systems that are not able to accept the Enerdrape system, or would have prohibitive costs if you need to redo the piping to the existing systems?
Yeah, so basically we install the panels on the source site. In general, we don't want to, let's say, connect to I mean, we are not changing the distribution side, so really the way heat is distributed in the building. So depending on that, the best, let's say, type of existing heating system is central units, because we can really combine and plug and play directly within the central unit of the building. And yeah, and then if the central unit is steam, is gas, is an overheat pump, or is I don't know, wooden based system, that won't really, I mean, it'll be easy to connect, because basically it's they still heat water up, so that's easy to connect to. So I would say if you have in the building electrical heating device, such as electrical radiators or very lots of multi-splits, here we will have to change fully the distribution system. So that might not make the most senses. But otherwise, as soon as you have a central heating system, we can basically connect to more or less everything.
Got it. Can strengthened versions of the panels be installed on garage floors on the horizontal surface?
Mm-hmm. So yes, but then you will have a lot of overcosts, and it could be basically very expensive, because you will have to build a full new infrastructure on top of the panels. The other possibility is to embed it directly into the slab, but then you don't have, let's say, access for maintenance. So this option is not necessarily recommended. So yes, we can do it, but let's say it's not necessarily the best option in general. Specifically if it's garage floors where you have circulation of vehicles. But for example, we do have this case in African country. They have a big anti-seismic chamber. So we actually are able to place the panels on the floors, because there is not, people walking around there. So it's a very specific type of volume, let's say, of technical area. So yeah.
Great. Another question, have you talked to New York City's Mass Transit Authority about lining the subway system's walls?
Yes, we did. Yeah, we are currently having discussions with them.
Great. And Alessandra, I see you've posted a point of clarification. Did you want to weigh in on this?
No, I think Margaux said everything. So I think, as she said, just maybe as a final point of clarification. So one panel is 1 square meter, which essentially equals 10 square feet. On an average, like on a 24/7 operation, it can provide an average of 100 watts. So you can consider that essentially one Enerdrape panel provides 100 watts. And then, as Margaux said, we typically have a ratio of 1:10. So essentially, the surface of an Enerdrape panel can meet the thermal energy needs of 10 times that surface in a building. And approximately speaking, you can consider to have really like this ratio of energy met irrespective of the building, irrespective of whether it's residential, commercial, whatsoever. We are capable of determining these aspects on a case-by-case basis, but in general, so thanks to the design of the panel and its minimal thermal resistance, it has a very high efficiency. So it's a it's a non-invasive geothermal solution that can really contribute up to meeting up to 100% of the thermal energy needs. It depends essentially on the volume that needs to be space conditioned above ground and below ground, but it's a possibility. So this varies on a case-by-case basis, but we are here to define these things for clients.
Great. Well, Alessandro, Margaux, thank you so much for your presentation today. And thank you to everyone who attended and the questions that everyone asked. We hope you can join us for our next session.
Thank you for the opportunity.
Thank you very much.